Do you have an experiment for us to show us exactly how this works?
Actually, this black body thing. So like let's skip to this picture maybe. So in here we see copper sphere tube, and incident radiation like enters, like hits to the copper sphere, and radiation starts heating copper, and we need to like emit all the we need to absorb all the sunlight in order to have more heat, right? So that's why people were using black paint. But like when we go hundreds years ago, when maybe like 200 years ago, people, they don't know this black paint has maybe absorption properties, right? It absorbs better. So the experiment they have conducted is about like black bodies, right? So this is normal glass actually, right? This is normal glass, and I use a candle and I heat it, like not heat it, but I use the flame of this, and it turns out to be like a little bit black. You see, in here probably light passes through the glass and from camera, and you can see my eyes, right? But if I like put the black side of the glass in front of the camera, you are not able to see me, because light, it cannot pass through. It is absorbed by this black surface, and this black surface is called soot, right? So when you heat something like soot, it's just carbon, nothing else, and it can take out just by doing this, like you see, and
Yeah.
here, and this black actually has 95% of absorption. 95%, like 95% of the light is being absorbed by this soot, so that you heat, you have more heat. So after this discovery, scientists, they started to do more experiments about light absorption, and that's the actually a breakthrough for space observations as well. Omash, how you can relate this with space observation? Like, how is it connected with space?
Like sun,
Like sun, how come?
because when it takes, like when it reflects light, it comes to us.
Nice approach. So how do you link those observations, Baha?
Could you repeat that?
Yeah. Like, how do you link this discovery that like people were using this suit, lamp suit, which can have an emission rate of over 95%, and this helps actually us to understand maybe different stars in the out there.
Well, yeah, I mean, the interesting part is emission and absorption rates are identical for every material because they're basically the same thing. So, in fact, as we sort of build our telescopes or the tools to detect the light that's being emitted by stars, for example, we need something that can absorb them well. And therefore, we actually do end up using these materials to sort of record, in some ways, the light that we receive. So, if you look at, for example, the internals of telescopes, the sort of tools that are in there to actually do the observations of the stars and planets and whatnot, they try to absorb as much light as possible. So they try to use these types of materials.
Yeah, see? Yeah. They were not astronauts so much, but after this discovery on the ground, it helped people to observe space better. It's pretty strange.
So what I'm getting from all of this is that black is a very important color to absorbing light and heat. And that means that we can heat our water for our houses. We can heat, if we're cold and we want to just get a little bit warmer under the sun, we heat our bodies. But it also helps us understand light and properties of light, but also kind of the properties of other things like the earth, maybe, or rocks, or even other stars and planets. So light is really, really important. In fact, without light, we wouldn't be able to see, right? So light's very important. It's got a lot of different colors, and those colors have meanings, right? So a blue star, for example, means something from a red star. And that difference is the temperature, perhaps, right? So I'm getting this sense that light is really, really important in our everyday lives. It's not just there for fun and colors, even though it is. Paint and all the colors in the rainbow are beautiful and make life really bright and happy, but it has science behind it. So I think this is a perfect time to go to the next slide that we have so we can look and see what color means and how it can change. So Omanch, do you see this color here? The balls here are we have like what 1, 2, 3, 4, 5, 6, 7 balls, right?
Yes.
How many color balls do we see?
3.
3 colors? Let's see. Perhaps we can ask our viewers. What? Yeah, how many colors do they think they see? So how?
Can direct the question. Yeah.
How many different color balls do we see are there in the picture? Is it A, 4, B, 3, C, 2, or D, 1?
This can't be this much easy. I mean, I also I think I saw like 3 different colors, but the question is kind of different. Omash has lots of colors. Yeah.
Yeah.
It is like
I saw 3 colors.
Yeah. But the question is strange. It says it doesn't say how many different colored balls do you see. Like it says how many different colored balls are there in the picture. Like so it's like there's a game.
That's a trick question then. There's a difference between that question and what I just said. So I see 3 different colors, right? But how many different colored balls are there in the picture?
Omash, why did you go far away from the screen? Why did you go far away from the screen? What were you doing?
Yeah. So the primary colors are red, green, blue.
Yeah.
And those are really important colors on how we see things. Ah, there he goes. Jihan's back. Of course, we can take a pause.
Just a second.
Of course.
Yep.
So while we're waiting, have you ever heard of something called an illusion? Like an optical illusion? Yeah, right? So in optical illusions, what happens? Like, what do you think? Like, you see something, but it's not actually what it is, right? In an optical illusion, you get tricked. Why do you think we get tricked? Bob, do you have any idea?
Well, I mean, you can think of it this way. The human eye has evolved for a very long time to suit our needs. And when it was sort of in this process of evolution, it prioritized the stuff that we actually need. For example, when you need to detect a predator that might be hiding between the grasses. Like, it's easy for you to see something if an object is a different color from everything else around. And the eye also has its shortcomings because those weren't necessarily problems that we had in our daily lives. And if you look at a human being's need for survival, trying to sort of understand how many of the colors are actually the same color and how many are different colors, that's not something essential that you need to know to survive. So the eye sort of has its shortcomings. When it was evolving, the priority was stuff that led you to survive it. So it simply didn't really develop in these other ways as well as it has noticed.
So, Amash, based off what Baha said, we see colors because of what reason? Because, like, we like them? Or we need them to survive? We need to see colors to survive? Or what do you think? I think I understood, but it looks like our eyes took a long time to come where they are right now. So there has to be a certain reason, right, why we see color. In your own words, can you explain what Baha said a little bit?
Like, it's the vision of the eye. Like, what we are seeing is sometimes not visible. And when we like clearly try to see it, or we try to look at it carefully, we actually find out what it is.
Exactly. So we focus, and we focus on colors, right? So if there's like a bird in a tree, and it's the same color as the leaves, it's green, it'd be really hard to see. But if it's a different color, it pops out and we can focus on that color, right? So our eyes evolved to see those different colors because it helps us see animals. So if we wanted to have that bird as our friend, we would be able to call out to it because we can see it. If we couldn't see it, we wouldn't even know that bird was there. Right?
Yeah, we are back in the game, by the way, and I think there was a problem with the internet connection, and now it's resolved. Have you found time to explain the illusion question?
In a sense, yeah. We've been talking about optical illusions and how sometimes what we see isn't exactly what's there.
Yeah, definitely.
So it's like a trick.
It is.
So we were talking about the colors on there. We see red, green, and blue lines. But it looks like, Omansh, do you see that brown ball? It doesn't have any lines on it. What do you think that means?
Means it is out of the line.
It's out of the line. It's visible to us.
And if you like check this picture, and the difference about this ball between those two pictures is only the red stripes on top of the ball is cleared in this version. So, and we see blue stripes on the top two balls. We see red stripes on these two, and we see green stripes on these two. So if it has green stripes, it looks like green, but it is actually brown. And how do you know that? Huh?
The stripes actually change the color of some balls.
Exactly. That's exactly right. So I think the answer to our question from before, how many different colored balls are there in the picture, we can clearly say that the answer is D, just one color, and that color is what, brown, was it?
Definitely. If we clear all the stripes, we will see that all balls are brown. And here is the three pictures together.
Side by side.
Yeah, side by
Wow.
side. It's pretty strange.
So, yeah. So, like, I think the lines really made a difference to how I see those balls. Even though they're the same color, my eyes saw like what, three different colors. I think all of us saw three different colors.
Definitely. Like I saw three colors in this picture, but this reminded me my like childhood times. Like nowadays we are playing like high resolution video games everywhere, and all the screens are like very like the view is amazing. But back then it wasn't like that. We were playing video games and they were building these screens. And Baha, maybe you can explain what is the like how people use this method, how they play it with our eyes and in video games. Yeah.
Yes, this technique of actually using the colors of what's around an object to alter how we see that particular object is something that's used in